Well, hello. In this episode of the WineDown, we're going to be talking about machine learning. So sit back and enjoy.
Welcome to the WineDown, an afternoon podcast where two techie blokes sit down over a bowl of wine and chat about what's happening in the world of tech. Enjoy while Scott and Nick open up about their week in technology.
Well, ladies and gentlemen, hello and welcome to the WineDown. My name's Nick and this is
Scott.
Hello, Scott. How are you?
Good, thank you, Nick.
Excellent. We're back again.
We are indeed. What a coincidence.
But where are we? And what are we drinking?
We are at the Sands.
We are in Narrabeen, in fact.
This would be classified as Narrabeen, I suppose. Yes, there's the beach out there, the sands and the waves rolling in.
Except we can't see those. We can see some trees and grass and stuff. But
Well,
I know it's there.
There's an assumed sand. The machine learning told me there would be sand with the beach.
Oh, there we go. Now, and what are we drinking?
Oh, I got a lovely Wolf Blass Grey Label, 2018. This is a great performer.
Yeah, it's not bad, is it? It's very nice.
No, look, the shows from the McLaren Vale area they always do a good job down there, and this has been around for a long time.
Yes, very
a
nice.
long time.
Very nice.
New French oak.
Mm-hmm.
And important, actually, the new part, strangely enough, is that's the crux of it. That's the bit that really gives the hit. And
of course. If you've used oak again and again,
it gradually, it's so you get a bit of new French oak, and then you can put it into older, like that. I think they use American oak for just a bit of long-term seasoning.
Cool.
16 months, and away you go.
So we're going to get to do a bit of a technical subject today, but we'll try and not make it too technical.
Okay.
All right, we'll try.
This will be interesting. We're really good at that.
Here we go. You can ask the first question.
Okay, so I guess, look, at a very broad level, what is machine learning?
Okay. Let me just work out how I keep it simple. Machine learning is unique sets of software that allow a computer to learn from data and be able to predict results. So, for example, if I was to give a certain computer program that we call a neural network 1 billion pictures, and each of those pictures had been tagged with English words. So this says a green apple in a vase or whatever it is. Then I should be able to give the machine learning algorithm the words, and it should be able to come back with a picture. And if you do that enough times, it will come back with a picture which exactly matches your words.
So provided there's enough what we call data points or enough information, it should be able to work things out.
Yes. And it does that in a kind of really unique way, which we believe mirrors how the human brain works.
Ooh, that's interesting.
So the human brain is made up of billions of neurons. Neurons are little cells that are connected to other cells, and those connections are fluid. They're variable. They change as you learn. So those connections change as you learn things, and it's the same in a computer. We have neurons too, and they connect to other neurons based on it learning.
Okay. Well, there you go.
There we are.
And some would learn faster than others, I would assume.
So you need an awful lot of computing power to learn, but once you've learned, to use the machine learning algorithm doesn't require very much at all.
Okay, that's fair enough. Interesting. And look, and we also know things about artificial intelligence, AI. You know, it's like HAL.
Artificial intelligence, like HAL, like, if you will, Google Assistant or Siri, or maybe Cortana to a bit. They're trying to emulate intelligence.
Okay.
Whereas machine learning is very different. It learns things and is able to predict results. And we can use that for data and images, but it's all about data. Whereas artificial intelligence is like an artificial intelligence.
Trying to work things out based or project things.
Yeah, the two kind of fade into each other. They're not really very distinct.
They do. And we hear about like things like ML and AI intermixed in conversations. And it's an interesting thing. So look, what's some examples, I guess, of machine learning in use today?
Well, let me give you a few. I'll start with some really simple ones that are in use in most cities in the world now.
Okay.
It used to be that traffic lights all worked on a timer. In fact, those of you who used to drive to work 15 years ago, you probably could have seen the light sequences as you drove into work. And now those aren't there anymore. And what's happening is computers are actually predicting when the best time to change the lights is to achieve the ultimate traffic flow.
Okay.
So they've done all sorts of analysis to work out what that is, and they're using ML to do that. And that's one you can't see, so that's a bit hard to see. one that's a very popular topic amongst it is, I think it was Target in the US, the big department store.
Yes.
An angry father walked in and said, "How dare you insinuate that my daughter is pregnant?" Because they tracked everybody who walked around their stores and what they looked like, and they surveyed a bunch of people as to where they were in life's journey, and they've been able to target that data with where people were and then start advertising them. So this young girl was getting adverts for, baby nappies and baby goods, and dad came in, he was very angry, and then he came in a week later, and the manager of the store was about to apologize, and he said, no, it's I who should apologize. I didn't know she actually was pregnant.
Oh, that's interesting.
That's why the machine learning algorithm had picked up what to advertise to her.
Oh, well, okay. Because I do remember that IBM had ads, quite a few years ago now, of how bad some of these prediction things were. You'd have people saying, I'm getting all these ads for stuff for my kids. I don't have kids. Or you're getting ads about, hey, you like to raft or on a boat. And I said, no, I don't. I get seasick. And that sort of thing. And they were saying that,
that's truly fascinating stuff going on in this space now. So, for example, what was going on? I think I was talking to my wife about something or other, and I dropped in the car to drop one of the kids off, and up pops up Google Maps, and its top 2 destinations for me were the 2 things I just talked about. Harry's Cafe de Wheels, that I've never been to, but it popped up as a destination choice, and I was like, what's going on here?
Who's listening into your conversations?
Well, the computer is.
Yeah.
And that's using machine learning to actually translate what I'm saying into actionable intelligence.
This is getting scary. A bit of Skynet in there, I think.
Not quite.
Not quite. Doesn't blow us up.
Not quite. And another example of machine learning is Tesla's autodrive. It uses a ton of machine learning to predict where the car's going to be and what other things are going to do as you move forward. And it's all machine learning is all about taking data, tagging it with an outcome so the machine learns, and then giving it the outcome and it tell you what data preceded it, or giving it data and it telling you the outcome.
So is this like the chess games that predict like 8 or 9 moves ahead, all the variations, and therefore know that if you move that, then hang on, that's following this path and we should do this.
And that's not really ML, right? Because that's finite path analysis.
Actually, that's true. That's true. It's not really learning. It's just following a defined, we already know what this looks like.
Yeah, whereas learning, you teach it in a totally different way. To program a chess computer, you end up programming every possible move of every possible thing, and that's not that hard to do in a recursive algorithm. But when you're doing machine learning, you're just giving it data. So you take, for example, every move of a Kasparov chess game, or every chess grandmaster, and you say, these 80 moves won, and these 90 moves won, and these 50 moves won, and you tell it which one's won and which one's lost, and it go win a game, move by move.
Yeah.
And it would then do it using prediction, so it uses a different type of technology.
Well, that's pretty cool. Now, I've started to see some of this in things like network management tools and automation tools, where, let's say you've got a bunch of switches out in your network, you've got a bunch of Wi-Fi out there, and the odd person has trouble connecting for some reason, and all of a sudden you start to get these emails saying, oh, we've noticed these events happening on your network. We believe this relates to this issue. You should probably look at this or this or this if you want to fix it.
Yeah, and this is why network vendors are now shipping their own management tools.
Yeah.
And one of the reasons is they want to collect the data of all the events that happen on every management tool, every device. They then want to come back to you or get people to look at them and tag them with resolutions. And so that over time with all of that, the computer will actually propose a resolution to you. And I don't know if you use Xero for accounting, you'd have noticed over the last 5-6 years, bank reconciliations getting easier and easier and easier. It's using machine learning to guess what your transactions are.
Very soon we won't have to do anything.
Well, that's the whole point of these products. Very soon you shouldn't have to do anything. And in network management, the systems should be smart enough, whereas we used to use humans looking at events to try and correlate them. Now the system should go to this device, do these 3 things, that will solve your problem you didn't know you had.
So how does this relate to things like cameras and tracking people moving around?
It's fascinating. So
but privacy act aside, just for the moment here, but the technology is actually quite impressive.
And it's been around for a little while, right? I was... in the 90s, I was working with a company that were doing license plate recognition. And that was really hard. And fingerprint recognition was really hard. Before we really did a lot of machine learning, that was really hard to code. That was really innovative. And one of the guys who used to work for me wrote a fingerprint algorithm, which was just awesome tech. But But with machine learning, this becomes different. You now say, this is a face and this is a human. And actually, one of my favorite parts, you talk about person tracking or face tracking. One of the things they're doing now is what's called gait tracking. So we all walk differently.
Oh, yes. I've heard about this.
They can actually work out who you are by how you walk. And they can track you, even if they can't see your face, by your gait. So if you're walking through a city and you've just committed a crime, they can track you just by the way you walk naturally or run naturally or whatever. It's just by your gait, which is fascinating. And that's all using machine learning to do that.
Gait being G-A-I-T,
Yes,
as in your...
no, not G-A-T-E.
No. Yes. Okay, let's at a technology level, that's quite impressive, and it's very interesting. At a privacy level, I've got some question marks around it, I must say. But anyway, it is what it is, and I suppose if you're in public, you're in public, in some respects. But hey, I remember, and I got this great bit of machine learning I'll tell you about. It's called Clippy.
Yeah, so Clippy's not machine learning, and Clippy didn't come out with Office, right? So it's the trick.
And I know it used to be called Clip It.
Well, no, before that, Clippy was a dog. And Clippy lived in a product called Microsoft Bob.
Ah.
And Microsoft Bob came out with Windows 3.0 as a totally different interface to Windows that looked like your house. And it had a filing cabinet, and it had a diary, and it had a clock, and it had a little dog that went around your house telling you what you should be doing, using really some very early artificial intelligence techniques.
Are you saying that's what Windows could have looked like if that had been popular?
Yeah, that wasn't very popular.
Really?
It was very, very unpopular. And certainly you can Google the stories about Microsoft Bob and have a fun time there. And I've got some stories. The one story, obviously Bill Gates has recently split up with his wife. But his wife, Melinda, was the group program manager for Microsoft Bob.
Oh, wow.
Yeah, so there you go. But Clippy and Bob were early digital assistants.
Very early.
What was funny is Clippy actually was able to do those. Those were programmable. They're able to do lots of different things. But the problem is when you start a Word document, it always looks like you're writing a letter. And it's very difficult from the first few words you type into a Word document for this thing to work out what type of document you're writing. So you always used to get, it looks like you're writing a letter. Well, actually, I'm not. I'm writing a resume, or I'm writing a this.
Okay. So Clippy pops up and says, hey, it looks like you're trying to do a podcast.
Yes.
So, but no one really seemed to have a positive thing to say about Clippy.
Oh, I think it became a bit of an early meme.
Clippy was certainly cute and had this little picture of this graphic trying to look like something, but...
Well, it could be other things as well. There was a wizard, there was the dog from Bob, there was you could choose what character you had, but you could also, there's an API for it. You could also code it and put it in your own applications. Guaranteed success there.
I remember there were a lot of characters, but every time you wanted to change it, you had to go and get your Office CD and put it back in to reload the new...
Yeah, there we go.
Anyway, so... interestingly, I was just looking at something about Clippy, and this fact popped up and said Time magazine included Clip It, which is Clippy, in a 2010 article listing it as one of the 50 worst inventions in the world. But I guess early days of machine learning and sort of the AI concept, that is...
early days of anything.
Yeah.
And the Apple Newton certainly wasn't very successful.
Oh, I remember that.
No, that was
an interesting device.
It's a horrible device, but the Scion Organizer was incredibly successful. But who won that at the end? It's technology. You have to ship what we now consider to be bad solutions in order for everybody to learn.
Version 1 has to get out there before version 2 can improve.
And you can't pick what the market's going to like. Certainly the Microsoft focus groups on Clippy. Focus groups loved it.
Okay, so next time you do something that doesn't work very well, you just say, well, we've got to try somewhere before we can improve.
We're going to blame the focus group and say version 2 will always be better, yeah.
That's right. So, look, behind the scenes, I know we've been working on this workflow solution for businesses, and it's what it can do is actually quite impressive. But how could machine learning be implemented into business workflows?
Well, kind of easily, if you think about it. So we'll go right back to the beginning of the conversation. What is machine learning? We give it some data, we tag the data, we give it some novel data, and it tells us how it should be tagged. So if you think of going through a workflow with multiple outcomes from something, if enough people go through that workflow and you know what the inputs are, you can build some training data for your ML algorithm. Your ML algorithm can get trained and then can come back to you and suggest an outcome.
So if 5 people upload a picture of a cat and go and tag it as a cat,
Yes.
It could be the sixth person that uploads a picture of a cat. The computer says, hang on, I know that. That's a cat, and tags it for you.
I would say if you've only had 5 people upload a picture of
Okay.
the cat, the algorithm will probably say cat. You need a bit more data than that.
Okay, but the concept of it's once it works out based on previous history what a pattern looks like.
Well, let's take a CRM example.
Okay.
Right? Customers' propensity to buy. So if you start asking enough questions and recording enough information about your customer, and it doesn't actually, it's not always the information you think it will be, which is what I love about ML and data. So let's say we'll record some information. We'll record the time of day we saw the customer, what the weather was, what color the customer was wearing,
Yes.
and whether they bought or not. And now if we put that and get enough of that data, we've got a big enough sales team, put that into an ML algorithm, it should, if you record that about a new customer, tell you how likely they are to purchase.
Well,
and it starts getting crazy accurate.
Well, strangely enough, for Microsoft partners, as we are one, Microsoft has just released a view of that. They've actually said, based upon all the clients in your sort of inventory list that you provision things for and do things for, we know, as Microsoft, I would say, when they go to our website, when they do a trial, when they do this, when they do that.
And we know what software they'll probably buy.
Yeah, and they're basically saying, as a partner now, we can go and get a list of, look, go talk to these clients. They're at a stage where they're probably wanting to go and do something. I thought, oh, that sounds really interesting. So I went and looked up on all this, and they all came back as very low.
Yes.
So it's just depressing.
Well, no, but propensity works far better for bigger customers.
Yeah,
It's very hard
I get
to do
it. I get it.
propensity for small businesses.
Yes, that's true too. But the concept was interesting. I do wonder at some point, is there a line here, or like an ethical line that sort of says, maybe I shouldn't be doing this in the first place? I don't know.
Well, look at, if you want to use a big machine learning algorithm, GPT-3, about to be GPT-4, has been trained on, you could consider it to be every document released on the internet. And it's really good at finishing your sentences, basically. It's crazy good at it.
At what point does it become so intrusive, though, that it becomes less effective having it there? Like, if I walked out onto the street and I took one step, and all of a sudden my phone beeps and goes, it looks like you're trying to walk. Would you like to buy some shoes? Perhaps it's cold. Would you like a jacket? Well,
it wouldn't go, perhaps it's cold. It goes, it is cold.
It is cold.
You
Would
need
you
a
like to buy a
jacket.
jacket?
Yeah.
There is a shop just around here. There's a special on. Let me ring them for you and tell them you're coming.
Yes.
I said, well, hang on. I just wanted to walk to my car over there.
I saw a wonderful bit of AI at a Google roadshow. They were demonstrating a system where you take a hairdresser who doesn't accept online bookings, and you have to phone and make the booking.
Oh.
Google's AI assistant
Yes.
can actually phone the hairdresser and successfully make the booking for you. That's
You know,
kind of wacky.
This is where I've seen the Google Assistant, hey Google, talking to Alexa, and you see them trying to converse.
Those
Now,
stupid YouTube things, yes.
It doesn't last very long, I must admit, before it just downgrades into a mess.
Yes, but it could.
But
these
you can
things
sort
could
of
get
see
better
where
and
it's
better.
coming from.
Yeah.
Yes.
And so things like natural language processing and that is going to get better and better. From our point of view in IT support, if you look across all of the tickets we get from all of our customers, there's similarities in there. There's multiple times we answer the same question. That's brilliant for ML.
It is, and there's actually tools around now, AI ops, as in artificial intelligence operations, that labelled well or not, I don't know, but uses a lot of ML behind the scenes.
Yep.
And it actually says, let us put it as a frontliner bot that has these 20 things knowing really well. If these are your top 20 issues, let us automate that for you.
Yep.
And such a client rings up, or client types in on the bot, or raises a ticket and says, I've got this problem. First response is, we have identified that problem before. This is the solution. Please do this. Now, I don't know.
So we wrote one of those years ago.
Did it just say turn the computer off and
No,
on
it
again?
didn't say turn the computer off and on again. It was actually real. So we'd taken all of our tickets. I had a work exchange student who tagged them all, and we took all of our knowledge-based articles and we put them. So we used two tools. We used a natural language processor to work out whether it was a support request or not. If it was, it went to the articles. And the day we turned it on, we got really bad feedback from our customers because they'd raise a ticket and instantly get a response. They knew it was a computer. So we put a random delay. We'd normally wait at least 30 minutes before going back with a response. And the response, instead of being, here's what you think your answer was, it says, hey, I've had a look at this. I think I've seen it before. Here's an article we wrote about it. Does that help? Let me know. Right? Bang, send, close the ticket.
Right.
Right? And the user would email back if it didn't help, and that would automatically reopen the ticket. So they never saw it, but we reduced our tickets by a crazy amount doing that, and we got good customer sat.
So hang on. By auto-closing your tickets, you've reduced the number.
No, because we'd given them an answer.
Ah, right. Okay.
Right?
Oh, now I understand.
There's no point holding the ticket open when you think you've given them an answer.
No,
You might as well close it
that
and
is true.
let them reopen it.
That is true. But there are a number of levels of automation now that we do see, at least in support calls, where most managed service providers, MSPs, will put a little agent on a machine that they're managing to collect stats and data and know when there's a problem, like, oh, you're nearly out of disk space, or hey, your CPU is running high for this, or whatever it is. And when a ticket gets raised, that data can get logged in with the ticket, and you can look at patterns and says, hey, my machine's running slow, and you look at that and go, well, this process has been running at 100% for the last 5 minutes. Therefore, it's probably a problem with this.
So I think what's happening with a lot of that, if you look at things like Splunk or Atlastics or those guys, they're doing really smart analytics on that data. I don't see a lot of ML there yet. However, the vendors I'm seeing start to do a lot of ML.
But that's really where it has to happen, because they're seeing the logic across the entire install base.
Yeah.
And this is also where you got to sort of have this thing about, do I want to allow diagnostic and usage data to be sent back to my vendor, or...
Well, I think you do. I think, because it's one of those
it can
things
help.
that's
It
going
can
to
help.
everyone.
Depends on what it is, but I think it can help.
Cool.
That's very interesting.
That was awesome. Thanks, Scott.
Well, I wonder if the machine could learn what we wanted to order next.
I'm sure it can. Absolutely. If not, I'll help you with that.
There you go.
Awesome. Bit of real intelligence. Thank you, Scott. I appreciate that.
Thank you, Nick.
And thank you so much for watching or listening. I hope you enjoyed it. Please leave us a like. And if you'd like us to discuss something, please put it in the comments. I hope you have a wonderful day.
Bye.
See ya.